What's up, YouTube? So I made a very simple Raylib app in these three different languages, C, Odin, and Zig, to see what it's like to get an application running with a very simple dependency. I also used three different editors to compare the editor experience. For C, I used my good old faithful NeoVim. For Odin, I used the Z editor without AI. And for Zig, I just used VS Code. This video isn't exactly a language comparison. It's more of a language tooling comparison. So what must one do to start integrating packages into a program? What's the experience like once you have builds working, and how is it to write code within within all of this? So the program that I'm going to show is very simple. We're going to show an FPS counter, and when the user clicks somewhere in the application, spawn a little red dot at the clicked location, and then we fade it out over time, over a couple seconds. The code structure is pretty simple. This is the pseudocode, but we have a couple of structs and we have a game loop. The structs are for the particles and the particles, and then the game loop is we clear the screen, we do things whenever the user clicks somewhere, and then we draw stuff that we need, and then we do some bookkeeping with the particles. And so the dimensions that we'll look at for this comparison today, we're going to look at installing the language, the build system, dependency management, the tooling, which is going to be the language server, and then performance to build and performance to run, which is going to be measured as average FPS, it's going to be measured as peak FPS. Sorry, ignore the parentheses. That's what they're there for anyway. Anyway, with the introductory stuff out of the way, let's get into the comparison. So the first one I did was C, and all in all, it was pretty simple. On Ubuntu, you pretty much get C and stuff for free. All you need to do is do a sudo apt install build essential. On other flavors of Linux, I recall it being also pretty simple, but I don't remember exactly. On Windows, it's a little complicated if you don't use WSL. I think you have to use like Visual Studio to get the C compiler, but anyway, so within my WSL, I use Ubuntu, so pretty simple. And then for the make file itself, it's real simple. We just have a clean target, we have a main target that builds the application, and then we have a couple of variables for the flags and the compiler that we use. So by using make and downloading the header and the lib files, you can also just kind of add the directories as flags, which is it's nice for kind of like ad hoc or like single time programs. You can also put them in your system directories if you plan to use Raylib a lot. But just for the purpose of this example, I didn't feel like doing that. And then setting them as flags also integrates well with like NeoVim's, Mason, and TreeSetter language servers as well. Like in this, I don't have my the Raylib headers in my system directories, but it still was able to pick it up because I set it as the flags. So to get into the application itself, or the program itself, we have this. So it's about 120 lines. Pretty simple. We're not going to go too much into it. We're just kind of like, going to look at it just as a demonstration, I guess. So this is pretty much it. So, as mentioned, we have the particles, and then some functions for those. We have the game data, which, holds all of the general stuff. And also, like, this is not exceptionally good code or anything. I just kind of like got this working and then was like, cool. So it's not impeccable code or anything. It's just okay, I guess. There's definitely a lot of stuff that could be changed. And that goes true for all of the languages that we'll look at today. So this is the application. I'll have a link to the repo later, but I think the important thing, or the next important thing we need to look at is kind of like what is like the building, and then also the performance, right? So how long does it take to build? How long does it take to run? Or how fast does it run once it's running? And so as we can see, like if we do a fresh build every time, it's really fast. It takes like less than about a tenth of a second, right? And then once we have that, right. Yeah, so I didn't have the library directory set in that environment, so it wasn't there. But yeah, so this is the application running now, and as I mentioned, anytime we click somewhere, it will spawn a little particle, and then it fades out over time. We can make a bunch of these. We can make up to 100 at a time, and then as you can see on the in the console, it is, it will like clear them out and let you reuse those indices. So. And then we also have a tracker for the peak FPS. So as we can see, it's getting to close to 600, but not quite getting past that. So yeah, so it's doing pretty good. It's done pretty good. So it just hit up to 605, so that's cool. But yeah, so that's the C version. So overall, for the scores, and again, just to be clear, like this is completely arbitrary. This is not like a super academic like study of these three languages. As you can see, like they all have the same weighting by score, and multiple languages can get the same score. So it's not like this isn't like a super in-depth comparison or anything. But anyway, so for installing the language, I'm just going to show all of them here. So for installing the language, I gave C an A because it's basically just baked into everything. For the build system, like if you can get by with makefiles, it's okay. It's not the greatest thing, but it's definitely not terrible. Dependency management is like, it's a little bit annoying that you have to like download and like pull up the dependencies and stuff, but overall it's like not bad, right? For the tooling, like as long as you set all of your flags and like basically any editor is going to have like the good language server integrations. So, that part's A+. And then the performance to build, like 1/10 of a second is incredible. It's pretty fast. And then performance to run is like, it hits up to like 600 FPS for this really simple program. Obviously, like, a real game is going to be more, it's going to take more work on the CPU, but still it's, 600 FPS is pretty all right. So then that adds up to a grand total of 16 points. So, pretty good showing from C. Not much it can improve on. So, it was only 2 points off a perfect score, but anyway, so also just a shameless plug. I have a video review for the book Effective C, which is excellent for learning how to write professional C. Also would be handy if you wanted to learn how to write, game programming C. So then with that out of the way, let's look at Odin. So installing Odin honestly was kind of the worst part of it, because mostly because the Mies package for Odin. I did a video on Mies as well, but with that tool manager, for some reason the Mies plugin for Odin doesn't work. So you have to use Homebrew or some other package manager. It's actually easier to install on just straight up Windows, because you can just use Winget. You can use Winget, Chocolatey, or Scoop. But with a typical Linux that doesn't have, like, Ubuntu doesn't have a distribution package for Odin, so you kind of have to just use Homebrew. Some distros do have an Odin package, like I think Arch does, but Ubuntu does not, so you have to use Homebrew, and it's a small minus there. But anyway, so let's do a little bit of looking at the build systems. So we'll look at Zig later, but for C with make, basically you run make as your build system, and then it has the definition of what compile command you're going to use inside of the make file. And so it's a pretty simple it's a pretty simple interface to the eventual build command. Odin is even simpler. It's just it's a subcommand of the Odin executable, and you just say Odin build dot, which is you say Odin build and then the directory that has the package that you want to build or run, and then it just does it, and it's great. So there's not really anything you have to do besides like set up your package inside of the code properly. And so once you've done that, then all of this, all of it, the build system is basically good. It feels very much like an Elixir mix or like a Rust cargo, where you set your stuff in the language and then everything just kind of works. And obviously, there are complicated setups that you can do where that's not quite true, but for this, it is true. So A plus. And another thing is that dependency management. It's kind of cheating in this one because Raylib is packaged with the language, which is really handy for any graphics programming that you want to do, or I guess Raylib programming that you want to do. But it also means that I couldn't get I didn't have to use Raylib as a package in order to get in order to try it. So what I did instead was we put the particle definition, just the definition, inside of a separate package within the application. And then the way that we reference it, so we call it this package particle, and then you import the directory, which is a little that took me a bit to figure out. And then once you do that, then you reference it as the directory name dot the entity within the package. So instead of mylib.particle, which would be one way that I might expect it to go, either that or just this, because usually the directory name isn't part of the isn't necessarily part of the the resolution of the thing, right? But yeah, so you do it like this, which is a little bit odd to me. But once you figure this out, then it's fine. So then with that, it's the program is about 107 lines. It's a little bit shorter than the C version because you can, I haven't looked into why that is, but a little bit shorter. And let's see. So for Z, it doesn't have the stuff built in, but there is a plugin or extension, right, for Odin that gives you the syntax highlighting and the language server stuff. So if I wanted to run a Raylib thing, then I get all of the autocompletes and stuff, which is really nice. So yeah, works great. Tooling is great. And then as for the performance, the build performance is kind of not great. It takes over a second to build this relatively simple program. We saw from the C version that it took less, a tenth of a second. So this is a order of magnitude difference in build time. But if we run it, move it to my normal screen, the performance when it's actually running is actually totally fine. It's actually doing better than the C version, which kind of peaked out at 605, but this one is peaking out at almost 700, and steadily increasing somehow. But yeah, so Odin, let's go back to here. Yeah, so Odin, let's see. So installing the language, I'm going to just unveil the thing again. Installing the language, I give it a B. This is obviously distro dependent. Again, this is not a super scientific comparison. This is just kind of my experience with it. If you can install it with Mies, then it'd be an A. But since it's since you have to use homebrew as opposed to your system package manager, and it's much easier on Windows, oddly enough, then it gets a B. The build system, however, A plus. Again, super simple. You just Odin run dot and it's great. Dependency management, I give it a B because it's a little bit confusing. And I understand why they do it like this, but the fact that you have to put your dependencies inside of your project is a little bit, it's a point of friction that most languages today don't really do. I understand why they do it like this though, because the creator of the language, Ginger Bill, which is what he goes by, he just doesn't like the way that package managers today are very they're very low friction, which means that you are kind of incentivized or encouraged to pull in a bunch of packages that you don't necessarily need. So I understand why they do it like this, but it is a point of friction. So the language server, A plus, works great. And again, Z, the Z plugin is works fine. I have used the NeoVim Mason language server, and it also works great before. The performance to build is pretty bad, so I gave it a C. But then the performance to run, actually, this should be a B. So I will let me fix that. Yeah. Which then means that this is actually a 14. Oh gosh. Okay. Sorry. I made this in spreadsheet and then I don't know why I didn't just share the spreadsheet. Anyway, overall score for Odin, 14. So pretty strong performance. Big minus in the performance to build, but everything else is pretty good. So with that, let's get on to Zig. Zig was by far the messiest. And we'll kind of get into that in a second. But let's see. So installing it is pretty painless. It is part of, it is something that you can, is it search? So you can get it with Mies and it works just fine. Let's see, sorry. The build system, that's where things get a little messy. So the build system is exposed through this build.zig file, which is basically just another Zig source file that has to define this build function. And so the thing about this is not that it was complicated to get this working. So whenever you create a new Zig project, you get a very big build.zig by default. And I've removed pretty much all of the comments and stuff that was not necessary to do this. But the big thing was really just that this is all I needed to end up doing was adding these 4 lines. And this was not documented. I had to go into the standard library documentation to find that these methods exist. And then also they don't take a string, they take a b.path, or they take a path. So you have to give them this thing that builds a path that is then recognized by these methods, which is, I don't know, it's it's one thing if it's documented well, but it's not. And so having to figure this all out is really annoying. But anyway, also I will say that this was just to make it, this was just to use the downloaded headers and library files that I used in the C version. There are some native Zig Raylib bindings, but I kind of wanted to try what it's like to just import a native C library. And this is all you have to do, but it sure doesn't make it easy to find that out. So that's my big gripe with the build system. Also, the fact that the language is changing so quickly means that documentation falls out of date, and I couldn't find any 0.15 guides on this. And so that's that's another thing to kind of keep in mind. And then another thing is once you do get it building with dependencies, the compilation error messages just aren't great. For example, so I had originally misconstructed this for loop to have, or not this one, this one. So whenever you capture 2 variables in a for loop in Zig, you have to put 2 captures in here. There's no way to just get just provide a single, an enumerable thing with an index, and then capture the element and then also the index. You can't do that without specifying the index as a separate iterable. And I did this in a couple of different places, and I only got a single, anytime I compiled, I only got the first instance of it as an error, instead of getting it in all of the places that it occurred. So that is really annoying, and I don't like that. I would like to get all of the errors that, within reason. I would like to get all of the errors whenever I compile, because the language server hooks into the compile system, or I guess it basically runs the build command in order to get its diagnostics, and the language server then also can't do more than a single error at a time, which is not great. It's not fun. But anyway, so you kind of move on to the tooling aspect. So VS Code, like the Zig extension is fine. I will say that I started off with Copilot autocomplete turned on. It was bad, which is not surprising. So I turned it off pretty fast, and I don't have it turned on at this point. But anyway, so then the next thing to look at is performance. And so for that, if you, in order to, like, there's no Zig clean, for whatever reason. So if you want to do like a clean build, you have to remove the Zig cache directory. And so if we do that, and then we time the build, like the just build step, then it's pretty slow. It's a little bit slower than the Odin version, actually. But once we have done so, then the performance is fine. It's not, it's not bad. It's not amazing. It's about on par with the C version. So that's kind of where it ends up performance-wise. So with that, let's let's take a look at the build system. So I guess the comparison to the other languages, with C, with make, like, you have this very simple, you have a make file, and that is just kind of an interface to shell commands. With Odin, it's basically just Odin build and Odin run, and it works great. With Zig, you have to specify your targets as well. So run is actually a target that's defined in my build.zig. And then inside of that, or what that then does is then it will run whatever is in build.zig, the build function. And you need all of these things in order to do the same thing that you do here in C, which is not in and of itself a problem. It's just that it's not documented well. And so, and also things change really fast. So, small annoyances. But anyway, so to look at these scores, so installing the language, again, you can just install it with Mies. So if you use Mies, then it's A+. If you use another system, then it's perhaps a little more complicated. I don't know. Again, not an academic, whatever. Build system, I give it a C because it's mostly for the lack of documentation on it. Dependency management, same. It's about a B, which is not too out there. I do know that it's easier if you have like a native Zig dependency, because then you can specify it as like you can have like something similar to like a package JSON with Zig, and then it's a lot simpler, I believe. But if you're just doing if you have like a C dependency, it's fine. Tooling, language server works great. I don't docket points for the compilation stuff. I think that's more of a build system issue, or I would call it a build system issue, I guess. And then for performance to build, again, it was about the same or like a little bit worse than Odin even. But then performance to run, actually this one should also be an A. I apologize for the slight difficulties. So then that gets like a 13. Okay, cool. So that's where we're at. So we end up with C in first place, and then Odin in second place with 14 points, and Zig in third place with 13 points. So yeah, I think I would generally agree with this ordering. I think Zig would be my last choice for a new project. I don't know if C would be my first choice. Actually, it probably would be. Yeah, probably would be my first choice. But I also really like Odin a lot. I have used it for I was building like a little tower defense game with Raylib, and it works really well. It's pretty fun to write. I like writing it. It looks really nice, and it's just a nice language. C, C is kind of goated with the sauce, and that's kind of hard to beat. I will say that like Odin has a smaller community and a smaller ecosystem, but the language is pretty stable, and the DX is really good. C, I guess like a lot of the nice things about C is that like it's it has like 60 years of history at this point, and that means that the stuff that's the paths are very well traveled, right? So the dependencies, if you need like a JSON dependency, like there's one best JSON dependency. If you want to figure out how to like deploy it to, to some like obscure Arduino or something, like someone out there's done it. You can't say the same for Odin and Zig probably. So, yeah. I will say that you do also have to implement more stuff yourself in C, like complex data structures and the allocators that accompany them. One thing that is nice about Odin and Zig is that they they provide like some allocators by default. So if you want to if you want to back some data structure with like an arena allocator, so that you're not constantly like pulling stuff off and off the heap and whatever, then they just like have them available, and that's pretty nice. And Zig has a nice testing allocator that you can use to detect memory leaks, which is nice. But all of that stuff you would have to implement yourself in C, which is, good and bad, right? But yeah, so that's my spiel. Again, this is not like a super serious comparison. It was just kind of something I, felt like doing, and thought I would share the results and see how people feel about it. So, go see. Thanks for watching.